Hello and welcome everyone to Red Planet Live. I am your host, Ashton Zeth. I'm elated to be hosting the Mars Society's podcast and leading the conversation about the human exploration of the universe and the future settlement of Mars. Now, as a longtime space enthusiast, I am passionate about STEM education and making humanity an interplanetary species. Thank you everybody for joining today and supporting Red Planet Live. I want to remind everybody that next episode, which normally would be scheduled for Tuesday, we have a special time for that one. We will be recording and going live for our next episode on Saturday, November 15th at 11 a.m. Pacific time. So put that on your calendar. We're breaking the regular schedule just this once. So Saturday, November 15th, 11 a.m. will be our next episode. We're going to feature Dex Hunter Torek, who was a speaker at the Mars Society convention this year. If you were there and got to catch that talk, so stay tuned. Excited to be chatting with him. So reminder: Saturday, November 15th at 11 a.m. Pacific time. All right. Well, I'm very excited to be chatting with today's guest. Today we are joined by Professor Sara Seager, who is an astrophysicist and a professor of physics, professor of planetary science, and a professor of aeronautics and astronautics at MIT. She's been a pioneer in the vast and unknown world of exoplanets. Her groundbreaking research ranges from the detection of exoplanet atmospheres, innovative theories about life on other worlds, and development of novel space mission concepts. In space missions for planetary discovery and exploration, she was the deputy science director for the MIT-led NASA Explorer-class mission TESS. She was also the PI of the MIT JPL CubeSat Asteria, is the lead for the Starshade Rendezvous mission to find a true Earth analog orbiting a sun-like star, and most recently has directed a mission concept study to find signs of life or life itself in the Venus atmosphere, and is PI of a mission to Venus targeted for in about a year. Her research earned her a MacArthur Genius Grant and other accolades, including membership in the U.S. National Academy of Sciences, the Sackler Prize in the Physical Sciences, and has been awarded one of Canada's highest civilian honors, appointment as an Officer of the Order of Canada. Professor Seager is the author of The Smallest Lights in the Universe, a memoir. Sara, thank you so much for being here. I'm excited to chat with you today.
It's great to be here. Thank you.
I love the telescope in the background, by the way. Kudos for good background. We love that. Well, on Red Planet Live, we do a segment called Question of the Day. So there's no right or wrong answer. It's just meant to be an icebreaker. I just want to hear your opinion and pick your brain a little bit. So my question to you, based on your background, let's say NASA lets you pick the next target mission. What would you choose and why?
That's a tough one. I think for the next mission, I would want to go to Venus, send a mission into the atmosphere with whatever it takes to find very complex organic molecules if they're there.
Mm-hmm. Okay. Well, we're going to focus on Venus a lot today. I know that's one of your major missions that you're working on right now. So let's jump right in. I want to remind those that are listening, if you have questions for Professor Sara Seager here, please put those in the chat. We will try to sprinkle those in throughout the conversation. But let's jump right in and start at the beginning. Professor, do you mind talking a little bit about your path to becoming an astrophysicist? Was there a pivotal moment or a catalyst that inspired you to pursue this career?
There were a few, and I just have to ask you, Ashton, do you remember seeing the moon through a telescope?
Oh, yeah. Yeah, definitely.
I have one of my first memories is I must have been about 5 years old, and my dad took me to a star party. That's not like the Hollywood movie stars, but when astronomers get their telescopes out and let people look through them. I remember seeing the moon. It was like, wow, it's a whole other world.
Mm-hmm.
And I'm a city girl. I grew up in the city, but I did get to go see, luckily, a dark sky when I was about 10 years old. And the same thing, when I first saw the dark night sky, I just, if I could have had a heart attack, I would have, because it's so amazing. I love that dark nights. And those just kind of stayed with me, not at the surface, but deep inside.
Mm-hmm.
And when I went to high school, I learned physics, which was so hard. But eventually I kind of realized, wow, we can not only explain the world around us, but we can answer our own questions using physics applied to astronomy. Mm-hmm. And I was sold.
Yeah. I remember the first time that I got my telescope, looking through that and seeing the moon and seeing how big the craters were. I mean, you see, if you've never seen it through a telescope, you see it in pictures, you see it in graphics, and you know that they're there. But getting to see them through the telescope, it took on a whole new meaning to see
It
those.
really does, and it's so amazing. It's a full moon now. Like tonight, I was walking my dog, and the moon is so bright, just rising and super bright.
Perfect timing for our conversation
Mhm.
today. We have a lot of students that listen to the podcast, and I get an opportunity to talk with students, K through 12 primarily, and encouraging them to pursue STEM and be interested in the sciences. Do you have any advice, or what would you say to encourage young people to pursue a career in STEM?
Well, there's so many things to do these days. One thing is get some solid foundation knowledge.
Hmm.
That's math, that's physics, that's computer programming.
Hmm.
Like, be sure to study the basics and learn them as thoroughly as you can.
Hmm.
That's pretty much the main advice. The second advice is find some fun doing it. If
Yeah.
you can join an astronomy club or your parents could join, be sure to be able to spend some time, like, outside looking at the night sky, at least for astronomy lovers. If it's chemistry, you have to try to do the same in chemistry, get a chemistry set, do some chemistry at school, that kind of thing. I'd say, like, those are, the fun part, whatever fun is for you,
Yeah.
and then the solid foundational learning. Those 2 things are number 1. But
Hmm.
number 3 is something we don't hear too often. I honestly wish they had a course in, we call it networking. Like, some people, maybe you're one of them, are just naturally outgoing, and you meet someone who meets someone who tells you about someone else, and before you know it, you get to visit a science lab
Hmm.
at your local university or industry. But
Hmm.
you really have to work that. Like, do you, maybe you can phrase that a little better.
Yeah, I mean, yeah, being open to connections and having conversations, and if you're interested in something, telling people about it, because you never know who they may know, and they're willing to put you in contact with. And like you said, you may end up at a science lab, or somewhere, or talking with somebody you never thought you'd get to
Mm.
talk to.
Like,
Um,
teachers are sometimes well connected.
yeah.
Maybe it's like parents of a friend, that kind of thing. It's you really just have to keep trying. Maybe if you have a doctor, you tell them, "Hey, I'm interested in whatever you're interested in." They might know someone. It's just like it takes a lot of time, and we never really teach kids this. It's not a thing you learn, like, in high school or middle school, but I wish we did. I wish we sort of, some people are naturally outgoing, and they lead to a summer job or
Hmm.
just, like, visiting a lab or shadowing someone for a day.
Hmm.
It's really important to work that.
Yeah, I got this question the other day from a parent, actually, and they said, "My kid is interested in science and planets and space, but I don't really know how to foster that, to encourage them, to inspire that curiosity." And so they were asking me for resources, or where do I turn? How do I do this?
I
How do
mean,
I?
it depends on the age of the kid, right? Like, if your
Yeah.
kid is, say, elementary school, they're not gonna be able to do stuff on their own. In that case,
Mhm.
get it. I remember one thing I did, I got a chemistry kit for my son. It was very basic, actually, but it involved a lot of work on my part, okay? But, you have to fo it's like a recipe book, it's like cooking,
Mhm.
like, you've gotta read through it and do fun activities together, that's one thing. Not everyone's lucky enough to live in a city with a science museum, but if you are, make sure you're going to that museum or get a membership. I
Mhm.
think there's a lot of different things you can do.
Mhm.
And I would
Absolutely.
say, fortunately or unfortunately, you now have ChatGPT and things like that to help you brainstorm. It's kind of overwhelming in a way, but you can ask ChatGPT and it literally will come up with, probably 5 or so terrible suggestions, but
Yeah.
there'll be a few really great ideas, great
Mhm.
suggestions in there.
Yeah, 1 or 2 good ones. No, that's a good reminder. Yeah, use the tools that you have access to.
Yeah,
So.
and I mean, there's a lot online for sure, but there's nothing that like the real world.
Mhm.
So just kind of getting out there and exploring and getting hands-on activities locally or even at your house is really the way to go.
Yeah, absolutely. And if you're interested and you're involved, it's going to encourage them to do the same. So I'd say be actively involved. Okay, well that's a great start, and want to focus on your background and the research that you're doing. We hinted at Venus, so I think we should pivot there, because there's a lot to cover with that. Can you talk more about your research into Venus, and why, or why not? Do you think it could be a viable place for a form of life in the atmosphere?
Yeah, let's talk about Venus. So, most people have some idea that Venus is so hot. It has a massive carbon dioxide greenhouse atmosphere, and the surface is like hundreds and hundreds of degrees Kelvin. It is too hot for any life we can think of. But just like on Earth, I don't know if you like, read about Mount Everest, or if you ever get to hike even like a small mountain.
Mhm.
It gets colder and colder the higher you go, right? Like, I know you live in Washington. I know you live in out west in the Pacific
Yeah.
Northwest. You know how like the mountains get snow first and
Mhm.
the valley doesn't? It's like, or if you go in an airplane, it gets colder and colder as you go above the surface
Yep.
of Earth. That's also true on Venus. So way above the surface, like 50 kilometers above, it's actually the right temperature for life.
Mhm.
And way up there above the surface, there are clouds there, and the clouds have liquid. So all the necessities for life, I mean, if we want to boil it down to a liquid, so chemicals can interact, the right temperature, so we can have complex molecules, and an energy source, the sun. I mean, it kind of, if we pare away all like the complexity, yeah, we have the right environment. But in the clouds of Venus where there's liquid, it's not liquid water. Like on Earth, we have liquid water clouds. There is life in our clouds temporarily.
Mhm.
The clouds of Venus, we know now they're made of concentrated sulfuric acid. Speaking of that home chemistry kit you might get your kid,
Yeah.
no, there won't be any concentrated sulfuric acid. That will burn a hole in your clothes and your skin. It's not really allowed. So anyhow, for a long time, a small group of people kept the idea alive that there could be life in the clouds of Venus floating around. But there's like kind of like a long convoluted story as to how we got here. But
Mhm.
my team started to put like not our life in concentrated sulfuric acid, but our biomolecules. And we discovered that some key molecules, like our amino acids, they are stable, with one exception, stable in concentrated sulfuric acid.
Mhm.
And we started to find other molecules, like our DNA is unstable, but parts of our DNA are stable. And we started like it's just the tip of the iceberg about that's the large reason why we believe there might be life in the clouds of Venus.
Mhm.
That are many, many, many biomolecules are stable in concentrated sulfuric acid.
Mhm. What research or evidence or data do we have so far that says yes, this is the place that we want to go, and this is worth spending the time, the energy, the funding to send a future mission there?
Well, what we have is laboratory-based work that shows complex organic molecules could exist in the Venus atmosphere. They could. We have from Venus, from past missions that over 4 decades ago went down into the atmosphere. The former Soviet Union sent over a dozen probes. NASA sent Pioneer Venus. We have
Mhm.
evidence. This isn't evidence for life, okay, but there's
Yeah.
very unusual chemistry there.
Mhm.
There's like the tiniest bit of measured oxygen, and it really is so reactive it shouldn't be present. There's tentative signs of ammonia, tentative evidence of controversial evidence of phosphine, gases that don't belong there, that shouldn't be there, but
Mhm.
yet are known to be made by life on Earth anyway.
Mhm. Okay, so some of those
I don't know.
precursors.
It is some kind of very loose, controversial, unusual gases. Okay. We don't know if that's from life or from something else. It
Mhm.
is the right temperature and liquid and energy existing in the clouds.
Yeah.
So it's really not that we're saying, hey, there's life, we need to go there. It's like, instead, we're saying, wow, let's go back there. Let's revive this idea that we can do something about it. We can go and check. And why not look? It's so close.
Mhm. Yeah. Okay, so the characteristics are in place. It's worth going to check out more. Go to
I
find out.
hope you think so. You don't sound
No, no,
convinced.
of course. I mean, hey, if there's any signs, I mean, that's a good place to I'd say, to spend the time and efforts. Everybody wants to know that there's life in the universe, that we're not alone. Maybe it doesn't look like us, but some form of life,
Maybe.
gives everybody
Yeah.
hope. And so
A
if
little
there's
bit.
a possibility, let's chase it. Let's go
And
there.
let me just say, like, I'm personally fixated on Venus right now.
Mhm.
I think there's so many places worth exploring. And I'm just kind of, highlight Venus as having been kind of overlooked.
Yeah. Besides Venus, we'll come back to that. I've got a couple of questions, but besides Venus, where are some other places that would potentially be viable or are worth looking at further?
Mars, right under the surface.
Mhm.
Mars is a favorite. Anything with water, Enceladus.
Enceladus, yep.
There's so many of Jupiter's icy moons, like Europa. Lots and
Mhm,
lots of places are amazing. Some people love Titan because it's got these liquid ethane and methane lakes.
mhm. And why for you particularly are you more focused on Venus than those others? What about Venus draws you in that you say this is worth the time and effort over, again, Enceladus, Mars, Titan, wherever it may be?
Because it's new. Venus is old but new.
Mhm,
I liken it to Do you have siblings?
I do,
What
yeah.
happened to you? Yeah, okay. You know, there's always the one sibling gets all the attention, and then there's the sibling who's always ignored, the quiet one. I don't know
Mhm,
which one you are, but I was yeah, but Venus is like that ignored sibling. You know, we have Venus, Earth, and Mars. Mars gets all the attention. Think about how many missions have been to Mars, where Venus, there have been orbiters sent, but in the last 4 decades, nothing has gone down into the interior.
mhm,
So it's really like that unknown one. I love new things, that are the underdog, the things that haven't been explored or that are not in people's minds. That's why it's attractive to me. But if
mhm.
you wanna know the honest truth of how I personally got interested in Venus,
Yeah.
I was on the team that made the announcement in 2020, in the fall of 2020, reporting a discovery of phosphine gas in the Venus atmosphere.
Mhm,
And we reported that, and we looked at every possibility of how phosphine could be on Venus. It's, you know, highly thermodynamically disfavored. It will not exist on its own. The element P doesn't want to go with H to make phosphine. It wants to go with O to make phosphates and other things.
mhm,
Well, we wrote 100 pages, and we went through every possibility of how you might get phosphine in the Venus atmosphere, and we showed that none of them work to match the even tiny measured amounts that were reported. So lightning, volcanoes, meteorites, like no way can make that much.
mhm,
And wow, this phosphine announcement immediately became incredibly controversial and still is to this day. The whole kerfuffle,
mhm,
it actually shone a new light on Venus. And that's why I and other people too just got a renewed interest in Venus.
mhm. I'm curious, as a non-scientist, I don't know what that is like, but when you make some announcement of a discovery, this is outside of the ordinary. We wouldn't have expected this. This is something new and worthy of more research. What's that experience like? And is that what most scientists are striving for? That big discovery?
Well, there's a bunch of things. You know how it's always like, is it the chase or is it like when you catch the prey? Like if you have like my dog who I adore, yeah, he loves just it's like the thrill of the journey mostly. So yeah, people are after something, but I do believe most scientists, myself included, it's the journey, like it's the thought of getting the big thing. So, well, it was tough because it's so unexpected. And we tried to craft a very careful message. And this was during the pandemic when not a lot was going on. So if no one
Mhm.
was sick in your family, you really just didn't have a lot to do.
Yeah.
And it was done by the Royal Society because the lead author, Professor Jane Greaves, it's really her project. She's a radio astronomer, and this was a radio signature of phosphine.
Mhm.
And she arranged this press release, and there were three of us. Herself, I think she went first. Then there were two others of us, and we had like 5 minutes each, and then we answered questions. And I distinctly remember, I had a slide saying, we're not saying there's life on Venus. We are saying that there's an unknown chemical signature, which on Earth is only associated with life, but
Mhm.
it leaves room for this possibility. We tried to phrase it like that. Like we didn't say, hey,
Mhm.
yay, there's life. We need to go there. We
Yeah.
said, hey, wow, we have this discovery. It's really, we described how we, did the discovery. And it really snowballed in a way that I didn't expect. Like on the one hand, the media loved it and they kind of jumped to, yay, there's life or there's definitive signs of life or,
There's
kind of
all
gets lost in translation. But
Yeah.
all of our scientific colleagues were livid. They were like so furious about this. And I still can't totally understand why. I mean, at least initially, their reaction was just one of almost horror.
Uh-huh.
It was a crazy time.
Yeah, interesting. Yeah, you'd think that, other scientists would be excited, optimistic, thrilled about, hey, there's something this precursor there for life. This is worth discovery. But yeah, maybe just the criticism or
Well, it
it's
just seems
negative.
so unusual. Like we're trained to be skeptics, but we're also born skeptics. So the
Yeah.
first thing when you hear something crazy is no. And then some people rush to analyze our data, and some people looked at the data. All the data is public. Eventually, it's taxpayer dollars supporting the large facilities.
Yeah.
And I'm really sorry to say that a lot of people, they didn't recover the signal when they analyzed the data. And
Mhm.
that's bad news. And it's just a tiny, tiny signal.
Mhm.
And it's a tough observation because our large ground-based telescopes, they're not, believe it or not, designed to look at something super bright like Venus. And it's moving across this, it's moving, and there's a lot of issues. So some people in one of our telescope data did recover the signal, and then they want to attribute it not to phosphine, but to another gas. So there's kind of a lot of layers of, I know you love Mars, and I don't know what your thoughts are about methane on Mars.
A lot of thoughts on that. Again, I think it's there. It's a sign. Nothing obviously definitive, but why is it there? It's worthy of more research, and that's why so many that are Mars enthusiasts are emphatic about we have to go there. We have to
Me
get
too,
humans
too, but
before we.
listen, this Mars story started 25 years ago or maybe more, when a
Hmm.
ground-based astronomers used big telescopes on Earth, and they found signs of methane
Hmm.
in the Martian atmosphere. No one believed it. Nobody
Hmm.
believed that. Years went by, and then, like, an orbiter saw it, and maybe another orbiter didn't see it. A rover found it. People claimed it was contamination on the rover, even though the instrument builder said it's not contamination. Like, there's still this kind of back and forth, and
Yeah.
when you probe the Mars community, do they believe there's methane? I mean, some of them reluctantly, and some of them don't actually. And so, like, the fact that we're still debating methane on Mars, 25, 30 years after its first ground-based report,
Hmm.
it just makes it a tough thing when you want to compare the phosphine on Venus story to that. So
Yeah.
I actually try to steer people away from phosphine. I'm like, phosphine happened, it's controversial. Let's just, put it aside for a moment. And wow, look at Venus. We forgot to consider Venus at the forefront. Let's reawaken our interest. Let's see what's there. And we did the laboratory studies, they're ongoing.
Hmm.
It's still worth going to Venus.
Yeah. Well, speaking of the phosphine, I see we've got a question here. How is phosphine made on Earth? Is one of the questions from
Good
Rob.
question. Really, really good question. It really doesn't occur without life. On Earth, it is made by us humans. We make it as pesticides, and we make it as like a toxin to kill things.
Hmm.
Phosphine also, it's very strongly associated with life, like bacteria in oxygen-free environments. People measure phosphine out in like wetlands and places without oxygen. And
Hmm.
when they bring like bacteria back to the lab, they can culture the bacteria and they find phosphine coming off of some bacteria.
Okay. Didn't know that. Let's see. We have another question here. Zap asks, could we get a balloon into the atmosphere of Venus rather than a probe?
Yes, we could get a balloon to Venus. And there actually have been 2 balloons sent to Venus in the 1980s by the former Soviet Union, the Vega balloons, and they lasted about 48 hours each. They had their own batteries. We could definitely do balloons to Venus again. There have been many, many studies coming out of NASA JPL. My own team has put some time and money into a balloon study by Maxim de Jong at Thin Red Line Aerospace. It's definitely possible.
Hmm.
When we think of going to Venus, there's a lot going on. The balloons are complicated, like complexity equals cost. And so when you think of going back to Venus, you really need to ask yourself, how much time do I really need to get what I want?
Hmm.
Sometimes you just want to get that perfect picture.
Yeah.
Today, I was trying to take this picture of my dog fetching a ball with the moon. I could have spent like an hour and like posed it all and like tried a million times, or I could just like get what I need.
Hmm.
So when you think of going to Venus, there's different philosophies. One is go for as long as you can with as many instruments as possible. But that kind of slows things down. We could have a different philosophy. It's like, I know what I'm looking for. I'm just going to send a quick mission, a probe. I'm going to get my data and I'll be done.
Hmm. Well, if you're able to get that mission to Venus, and you're looking for signs of that organic chemistry, what could that mean for the future of astrobiology and astrophysics in the future?
Sorry, I was reading the questions in the chat. Can you just
Oh
repeat
yeah.
that?
So if those mission to Venus, you're looking for signs of life, but the organic chemistry, what would that mean if, say, you're looking for that phosphine, or you're maybe not going in with opinion. I'm looking for this, and this is why I think it is that way. But you're going in. We want to just get the data. What is there, and maybe we can uncover what is where it's from, what's causing it. What would that mean for the future of astrobiology?
Well, there's so many layers here, to like find an incredibly robust sign of life. It's not going to happen right away.
Hmm.
We envision going to Venus with a series of missions. And one of the missions we want to do is, we do want to do a balloon, but we'd like to do a parachute mission beforehand. And
Hmm.
we'd like to be able to identify, like literally find classes of complex organic molecules. Like
Hmm.
think of ringed molecules, like we have benzene and related molecules like that, or amino acids or related to amino acids molecules. We'd like to send some miniature molecular sensors that are designed to meet, like a jigsaw puzzle, to fit together to
Mhm.
find very specific molecules of interest. That's kind of like what we'd like to do, to show
Mhm.
there's complex organic molecules. It doesn't mean there's life, but all life needs complex organics. And, for astrobiologists and scientists, we draw a line somewhere where on the one side, these organic molecules could just be made by nature, like even in Venus, just kind of by photochemistry or just by chemistry. And on the other side of that line, they're so complex, people would want to argue or even insist that they're made by life because they're such complicated molecules. That's
Mhm.
tricky. We don't know where to draw that line. But
Mhm.
if we could go there and show there's like a wide variety of very complicated organic molecules, that would give motivation to then send a balloon or a mission that's more sophisticated to really try to find more robust signs of life.
Mhm. Besides the phosphine, when I in preparation for our conversation, reading some of the articles and on your website about the Venus mission. Besides the phosphine, I think I read something about maybe something about UV. What else stands out as most intriguing besides the phosphine that we're finding in with those amino acids, like you mentioned? Any other elements?
Let's
Any other?
talk about UV for a moment. So,
Yeah.
what's really intriguing about Venus, and this has been known for many decades, it's just simply called the unknown ultraviolet absorber. On Venus, half of all incident sunlight is absorbed, and nobody knows what it is that's doing the absorption. Like the
Mhm.
clouds themselves are strongly absorbing, and in the top layer of the clouds, all the sunlight is getting absorbed. And when you look at Venus and you see this kind of V-shaped, supposedly those are where some of the absorption is happening. And there are a lot of different ideas. They're probably all right. I mean, it doesn't just have to be one thing that's doing the ultraviolet absorbing.
Mhm.
Excuse me, a lot of compounds doing it. So one of our favorites is that there are organic, of course, I mean, you won't be surprised if I say one of our favorite ideas is that there are organic molecules doing the absorption that are
Mhm.
ultraviolet absorbing. But yeah, the ultraviolet absorption is very intriguing.
Mhm. And let's see. Oh, yeah, that answers the question about somebody had asked about the unknown UV. So there you go. You hit on that one already. I'm. Oh, there we go. Now we can see the question. Oh, there we go. What would be your guess of what unknown UV 200 250 nanometers absorption feature? Anything you want to add on to that comment? I know we kind of alluded to that question, and then we put it on there. But
I mean,
yeah.
like the most speculative thing people want to say is it's some kind of pigment. Like, how chlorophyll absorbs in the visible on Earth. They want to say it's some kind of life with some kind of photosynthetic pigment. Other people say it's like iron chloride or it's some kind of, you know, iron compound. I really like the idea that they're organic molecules. And one of our extended team members, his name's Jan Spacek, he actually demonstrated that if you start with a simple organic molecule, like that could come from a meteorite or come from photochemistry, and you put it in sulfuric acid in the lab and you heat it, you actually can get a rich organic chemistry. And these organic molecules that he found in the lab, they actually could be responsible for this very strong, what it's saying here, ultraviolet absorption, blue absorption. So that's my favorite idea. But honestly, there's probably a lot of ideas that are correct.
Mm-hmm. Yeah. Well, more reason to keep researching, get those missions there. So besides Venus, of your research has covered exoplanets. Of all the exoplanets that you and other scientists have discovered or researched, is there any others that are particular that you think are best chance for hosting life, or worthy of additional research?
Well, we're trying to open our minds right now because a true Earth twin, like an Earth-sized planet in an Earth-like orbit about a sun-like star, like our true twin, it's far off for us to discover. We
Mm-hmm.
can't find another Earth yet. We can't study its atmosphere to look for signs of life. So when we're trying to expand our minds now because if we can't find an Earth twin, we still want to find signs of life. And we're just thinking of like Earth cousins. So now it's not your twin sibling or your sibling, but it's maybe think of like there's someone in your family and they're like a different
Mm-hmm.
age, and they're in a different country. It's like that. We're trying to be as generous as we can in what could host life. So right now, one of the things that people are focusing on are the so-called sub-Neptune sized planets. They're
Okay.
planets that are bigger than Earth, but smaller than Neptune.
Mhm.
Okay, it's not an inventive name, sub-Neptune. But okay. But these sub-Neptunes appear to be the most common sized planet in our galaxy, but we don't have one in our solar system. Some of them are one of the iconic ones is called K2-18b. They just get named after their survey.
Mhm.
And some people have tried to claim that there's signs of life on K2-18b. So it's a planet about twice the size of Earth, so it's bigger than Earth.
Mhm.
It may or may not have water oceans beneath like a massive hydrogen atmosphere.
Mhm.
And they found some signs of it's not clear if it's I mean, okay, it's kind of like the phosphine story all over again, but tiny signal, very noisy data claim that it's a molecule called dimethyl sulfide, which is a gas on Earth that's made by life. So we're trying to open our minds about what could it be? Could there be hot water oceans with life? Could there be life in clouds, water clouds of sub-Neptunes? We're not really sure. So I think that's one promising place. Well, it's kind of like the person who that story where the person drops their keys outside at night, but they're looking under the street lamp because
Mhm.
that's where you can see. They're not looking where else it might be because it's so dark. So we're
Mhm.
kind of grasping at straws here, but these sub-Neptune sized planets are the ones that people are focusing on now because they have good observational signals.
Mhm. How do you look outside of that street lamp lighting? I mean, what does it take to say, "Nope, we're not gonna focus on this area that we can see that's observable, but, we need to look outside of that." What is the limitation? Is it funding? Is it technology? Is it resources, time and energy? Why can we not focus outside of that street light?
Well, it's some of everything. Some of it is our own imagination. We're always limited by our own imagination.
Mhm.
And there could be other planets that have liquid on them that we just haven't really thought of yet. And I have a real example I can give you. We
Sure.
can maybe circle. Okay, maybe I can talk about it just very briefly.
Yeah.
Well, my team accidentally rediscovered a kind of liquid that is incredibly difficult to evaporate. Like, do you know when you spill water and it just evaporates off your table or floor? There
Mhm.
could be an entire class of planets that are too warm with too thin atmospheres for water. But there
Mhm.
could be another kind of liquid, and it's called an ionic liquid.
Mhm.
So it's held together by super strong bonds, just like your table salt, only it's liquid at under 100 degrees Celsius.
Mhm.
And we like accidentally rediscovered these ionic liquids, and we described the first one that could be made out of planetary materials. Here on Earth as well, we have volcanoes like and vents that are giving off sulfuric acid.
Mhm.
And if you could have a planet that has sulfuric acid coming out of a volcano, and if it lands on nitrogen containing organics, it's kind of like a complicated story, but as long as the excess sulfuric acid dissipates into rocks or evaporates, you literally will be left with this ionic liquid that has a vapor pressure so low, like it could be orders of magnitude lower than water. It literally doesn't want to evaporate.
Mhm.
It was a bit of a complicated story, but I'm just saying there's room for new things that we haven't put together yet, knowledge that already exists on Earth that we haven't yet applied to planets. So
Mhm.
one reason is just our limited imagination, but the other one is resources and technology. And I want you to think for a moment about our Earth. It feels big, right? Like to drive across the USA takes 5 days, maybe
Mhm.
4 if you're, hoofing it.
Yeah.
So I feel like Earth is really big. But when you think about Earth compared to our sun, it is so tiny.
Mhm.
Our Earth is like 100 times smaller in size, 300,000 times less massive, and 10 billion times fainter. So any technique to find another Earth, you need to, Earth is so close to the star. Another Earth, other planets, they're so close to the star. We have to deal with the star. It's like the proverbial elephant in the room.
Mhm.
And so our technology is not there yet. We can't, handle finding a planet that's so small, so low mass, and so faint compared to its bright host star. So we definitely have been investing, like NASA, NSF, everyone has been investing in new technology, but it would just take so much more to reach it. So looking, away from the streetlight, so to speak, it's expanding our imaginations for one with the tools we do have, and then
Mhm.
it's new tools that are more capable that we don't yet have. We don't yet have commitment for resources.
Mhm. On the podcast, we've had a range of guests, scientists, researchers, And we've talked about some technologies and potentially technologies that are in development. We wish we had, but we're not there yet. Could you give your opinion on, hey, again, looking outside of our imagination, but looking outside of that streetlight, what type of technologies or where could we use more innovation so that we could have the technology necessary so that we could continue looking further outside of that streetlight?
Well, my favorite technology for finding and studying exoplanets down to Earth-sized planets is called starshade.
Mm-hmm.
And starshade is a giant specially shaped screen. It's like a giant sunflower. And
Okay.
starshade would be in space, and it would be tens of meters in diameter. And it would formation fly with a space telescope, but they would have to be spaced out at tens of thousands of kilometers.
Mm-hmm.
And the starshade would literally be like blocking out the starlight so you can see the planets directly.
Mm-hmm.
But because an Earth is 10 billion times fainter than another sun-like star, the starshade has to be incredibly precisely shaped, and it has to be incredibly like lined up with the telescope to block out the starlight to allow the planet light through.
Mm-hmm.
That it's just very complicated and expensive.
Mm-hmm.
So,
Okay.
yeah. Let me
Pulling on
just reinforce
that
that. I might have to just explain that one more time.
yeah.
On Earth, you know, our atmosphere has a massive blurring effect. It is like, do you ever go swimming in a swimming pool or a lake and you look up and you just see like giant blobs?
Mm-hmm.
That swimming pool, like it has these kind of giant cells and you can never see the surface, right? Like if you have a friend at the surface, you can't really see it clearly.
Yeah.
That's what the night sky is like to our telescopes, exaggerating a bit, that the turbulence, like the air moving around in our atmosphere, kind of blurs.
Mm-hmm.
And it doesn't let us like find really tiny planets.
Mm-hmm.
The idea is to go to outer space above the blurring effects of Earth's atmosphere to block out the starlight so we can see the planet directly. And there are a lot of different ways to do it, but starshade is my favorite.
Mm-hmm. Is that something that's currently in development? Starshade, is that something that is currently being worked on, or
It's not actually now. I have a website called projectstarshade.com where we're trying to keep starshade alive. But starshade was quite well supported by NASA for, I want to say, 10 or 15 years. And I got to lead it for a few of those years. But
Mhm.
starshade has been brought along extremely far. And it has now, not totally, but more or less been put on the shelf for the
Mhm.
time being in favor of a different technique called the chronograph, where there's a device inside the telescope that tries to block out the starlight so we can see the planet directly.
Mhm. Let's see. I think we've got a question about it. So, speaking of starshade, what are your thoughts of a permanent telescope on the far side of the moon? Question from the audience.
Good question. People love the far side of the moon. It's well, it's very radio quiet. Mostly the far side of the moon is taken seriously for radio telescopes because you can, have a giant area and put your telescope elements all spread out. And we don't see the far side of the moon. And so it's radio quiet there. There's no radio waves hitting the far side of the moon. So it's good for that. For actual astronomy itself, like visible wavelength or infrared, it's not necessarily the best place, actually. You know how it gets bright over there on that far side. And there's a lot of dust. There's a lot of like regolith, and that dust is really bad for astronomy. And we can't really go and fix it or anything. So
Mhm.
getting to space to like a favorable orbit generally is better for general astronomy.
Mhm. Let's see. Roger asks, what are the ions in the ionic liquid you discovered? What elements make up the ionic liquid?
Okay, good question. So I always call it a rediscovery because there's about 1,000 ionic liquids known, and I call it rediscovery because we rediscovered it in the lab, kind of by accident. But what it is it's sulfuric acid, and I want you to think of an acid as a substance that wants to donate a proton. It wants to give away a proton. That's kind of like a high school definition. And when I was telling you about amino acids, those are organic compounds that have a nitrogen atom. And you know what? Nitrogen wants to receive a proton. So it's kind of like the perfect marriage because sulfuric acid wants to give away a proton, and it's like nitrogen containing organic molecule, amino acid, or some others, it wants to receive one.
Mhm.
That means that the sulfuric acid, or what's left of it, becomes negative because it gave away a plus. but that plus that got added to the other molecule, that's now positive.
Mm-hmm.
So we call it like a hydrogen sulfate ion, and then pick an amino acid like glycine, for example, just call it glycine plus. And then they just lock together because one's negative, one's positive, and they just want to join.
There we go. Okay, you guys are asking great questions. Keep putting those in the chat.
We can talk about, I saw a question about the Rocket Lab mission to Venus. Should we answer that one?
Oh, sure. Yeah. Go ahead. Let's do that one.
Okay, so right after the phosphine on Venus announcement, I got some seed money and I convened a team of people. And I handpicked a team of people. Only one had worked on Venus. I also handpicked it to avoid any cranky older people, because I wanted to have fresh voices and rethink from scratch, like what missions could we send to Venus? Small focused missions that could jumpstart the search for signs of life or life itself. And we met weekly. We opened up to the community every quarter. So sometimes we'd have like 80 people show up.
Mm-hmm.
Our meetings were more like 10 people. And one of the people who came to our meetings was Richard French from Rocket Lab. He's the new business person for Rocket Lab. And after some time, he told us that Rocket Lab wanted to go to Venus. And would we as a science team like to join forces? So we joined up with Rocket Lab, and the Rocket Lab rocket, the Electron,
Mm-hmm.
it has launched, I want to say it has launched over 70 times. Lots of rockets. So it's a small rocket, and it can only carry like a small amount to Venus. So we agreed that our first mission, we would join forces and we would call it the Rocket Lab mission to Venus. So I was responsible, or am responsible, for the science team and the science instrument. And our science instrument on the Rocket Lab mission to Venus has been built by Daryl Baumgartner at Cloud Measurement Solutions out in Colorado. And we have just one instrument, and it weighs 1 kilogram. It's very light.
Mm-hmm.
And it'll shine an ultraviolet laser through a sapphire window in the pressure vessel and through a hole in the probe, and it'll look for fluorescence. You know how like a nightclub or a kid's fun house, there's like a black light, and you know how your white clothes will like light up really bright? Yeah, we're kind of doing that.
I love all of your analogies. Yeah, I totally know what you mean. Yeah.
You know what I mean? So we have to go on the dark side. We've got to land. We have to go through the atmosphere, not on the day side, but on the night side. And we're going to look for like fluorescence, which would be a very strong indicator of organic material. Because sulfuric acid, what the clouds are made of, doesn't fluoresce on its own. And organic materials very, very easily fluoresce. We're also going to measure the backscattered radiation, the backscattered polarized radiation, because that will encodes partly what the particles are made of. And past missions have included a backscattered radiation measurement. And we're going to, again, we're trying to confirm that some of the particles are not pure concentrated sulfuric acid, but deviate.
Mm-hmm.
So that is the first in the series of our missions to Venus.
Very cool. Okay. So is that, are you partnering with Rocket Lab on all the missions to Venus, or that's the primary partner for those? Multiple.
I would absolutely love to partner with Rocket Lab on all of the missions.
Mm-hmm.
They're amazing. We've only had good things. I only have good things to say about their engineering team, but the future missions are going to be TBD. We're sort of working on developing them now, and we're figuring out who's going to build our next mission, which we don't have funding for the next mission yet, but it's all going to come together soon.
Yeah, that seems to be the constant. Always working on funding with everybody that I talk to. That's always the hurdle to jump over. Let's see. Well, I wanted to ask you specifically about a video that I saw the other day. Recently in the news has been covering reports about I think it's 3i Atlas, an object spotted cruising through the solar system. Can you share any insights into this object? Why is it so fascinating? Why is it capturing everybody's attention, and why could it potentially be significant?
Well, it appears to be our third visitor from another planetary system. And that is pretty cool.
Mm-hmm.
We have had others, you've heard of Oumuamua, and I'm blanking on what the second one was called, but I think it's absolutely fascinating. Like, imagine that we didn't know of any of these before, and now within the span of a few years, we've had 3. So it must mean there are many, many more that just haven't caught our attention yet. So I'm just going to kind of go over the bigger picture for a moment, because these objects, they're just going so fast, and their trajectory means they're not orbiting our sun. And then, they'll go through our system. They will gravitationally get maybe perturbed a little bit, like
Mhm.
knocked a bit by our sun, and then they'll just go off. Who knows where they're gonna go next?
Mhm.
So there's that. There's been one person who's trying to push the idea that some of these may be like alien spacecraft because
Mhm.
they behave strangely. They look different. But this one that we have right now, Comet 3I Atlas, it looks like a comet as far as we can tell. Like it's, got the coma and the tail, and it's appears to be giving off gas as it gets closer to our sun. So for all we can tell, it is a comet. It's very massive, though, more massive than we would have expected. But then again, we don't really know what to expect.
Mhm.
So I think one thing is to keep our eyes open for more of these, or keep our eyes open for the news or for reports of more of them.
Mhm. Has it gotten brighter in the last few days?
I haven't been following it closely enough to answer that, but
Okay.
possibly.
Okay. And I think I saw in the video, which was like a half an hour long, and information overload. It's like, okay, there's a lot to this. I think the color had changed, which was unique or interesting, and again, another sign that maybe this is not something standard. But again, to your point, maybe it's an alien spacecraft of
Oh,
some
right. Well, I remember now. I don't remember the details, but I remember, yeah, people are trying to find out what is it made of.
kind. Mhm.
And if we can find out what it's made of by the gases it's giving off, we can try to piece together if it's a comet like those that exist in our solar system, or maybe it formed differently, or maybe it formed in a different region of its planetary system. So there's all kinds of clues there. But
Mhm.
this one, as far as I've read, it really it's not it really seems to be like it's behaving like a comet. There's that phrase, like, if it looks like a comet, if it, smells like a comet, if it
Yeah,
acts like
yeah.
a comet, it's a comet. So I think that one's pretty non-controversial for what it is.
Okay, okay, debunking the, conspiracy theorists online that it's some sort of alien spacecraft. Um, well, that's very interesting, and we'll be excited to hear more about it. I believe they're using either it's James Webb or it's Hubble to try to capture some images of it. And I believe I saw on your website that you had worked on some of those missions or had some involvement in the various telescopes. Can you talk about your involvement with those and what were you researching? Did you have instruments that were on the telescopes? Tell us
Sure.
more.
Well, the James Webb Space Telescope is like an incredibly sophisticated telescope. It's not called the People's Telescope, but we can all propose to use it.
Hmm.
You could all, if you can figure it out how to propose, anyone's allowed to propose to use the telescope. There's actually like a double blind review process. So if you
Okay.
propose, they don't know it's you, and
Hmm.
you don't know who's reviewing it. But it's very oversubscribed. So for every 10 proposals, maybe one will get accepted.
Hmm.
Very competitive. There's just not enough time to go around. But
Right.
I didn't build an instrument, but like everyone else, I'm a user of the James Webb Space Telescope.
Okay.
A mission I was more closely involved with is the NASA TESS mission.
Hmm.
TESS is like the girl's name, TESS, but it stands for Transiting Exoplanet Survey Satellite. And TESS launched in 2018. And TESS is 4 cameras. Like, think of 4 glorified telephoto lenses. And the lens diameter is like about that big. It's about 10 centimeters across,
Hmm.
but it has like giant baffles. So the lens assemblies look really big. And the 4 of them are bolted to a platform, and all of that is on one single spacecraft. And that spacecraft orbits Earth in a giant elliptical orbit. And it takes 13.6 days to go around Earth. And it's kind of an interesting orbit because it's in resonance with the moon. That means that when TESS goes around one time, the moon is over here, and the next time it goes around, the moon is over here.
Hmm.
So TESS goes around twice for every time the moon goes around Earth once, and the moon stabilizes the orbit. So TESS could last, like its orbit, it doesn't need a lot of fuel to correct where it is. It just kind of keeps going. And
Hmm.
what these 4 cameras do is they're lined up in a way that they observe a giant strip of the sky, literally like 90-degree long strip. You know what that means, right? It's almost like from the equator to the pole, like a huge
Okay.
strip of the sky.
Okay.
And it stares at that strip for a month, 2 orbits. And in that strip, there'd be like 100,000 bright stars and like a million or 10 million stars altogether. And all that data is observed and it's downlinked. And our computers are looking for a tiny, tiny drop in brightness in each of those stars. A drop in brightness that has a pattern that might indicate there's a planet going in
Hmm.
front of the star and making it dim, and then every orbit going around and around. And my job on the TESS mission back in the years leading up to and after 2018 when it launched, was to help set up the end part of finding planets. So we literally had to help develop like the software and the team. I had to like help organize everything to identify the test objects of interest, the planet candidates from all those light curves that would then go out for follow-up to validate whether or not they're planets.
Mm-hmm.
We literally would be finding like 100 planet candidates a month. How cool is that?
Very cool. Yeah. Who else can say that? I mean, I'm not sure that there's, many other scientists out there that say, hey, we're finding this many planets. So what is the current status of that test mission now? Is it still? Oh, go ahead.
TESS is still going. Every space mission gets a budget for a certain number of years. So TESS took 1 full year to tile the southern hemisphere, like, one strip of the sky and then moving around the sky until it completed the southern hemisphere, 1 year on the northern hemisphere. And that was the prime mission, was just to cover the whole sky one time.
Mm-hmm.
But every mission, including Hubble, every 2 years has to go in front of a committee called the Senior Review. And it gets rated, like, is it worthy to like live on and get more money, or is it not worthy and should be shut down? But usually missions do get to keep going because most of the cost is in building and launching and getting it operational. Once a mission is working, it's usually not as much, very small fraction to keep it going.
Mm-hmm.
So TESS is orbiting Earth, and it literally could orbit for like 1,000 years without too much fuel spent to maneuver.
Mm-hmm.
So it's been orbiting since 2018. It has been finding planets, and it's been finding a lot of other cool things in astronomy as well. So it'll just keep going.
What are some of the other cool things that it's been
Okay,
finding?
well, the coolest thing I personally think are, do you know what supernova are?
I'm familiar with the term. Yep.
So supernova are like exploding stars, basically.
Uh-huh.
And when they explode, they get super bright. Like back when I was a teenager, there was supernova 1987A and 1987 that someone literally saw with his naked eye. He was in the southern hemisphere at a very dark sky, being a telescope. Like he had astronomer. He was an astronomer. And he looked at the sky and he's like, that star shouldn't be there. Wow, can you imagine knowing the night sky so well that you could look up and realize the star was where it shouldn't be?
You can pinpoint one and say, that's not right. Yeah.
He said, that's not right. And that was a supernova. That was a star that had exploded.
Mm-hmm.
But these stars explode, and then over time, they drop off in brightness. Okay. And astronomers have like ground-based surveys that are like looking at around the sky, looking for these things. But what's so cool is because TESS is ongoing, like it will stare at one part of the sky for a month. So let's say you, Ashton, you've got a telescope finding supernova, but you're moving around the sky. And so you find one, but you wouldn't ever find it like exactly when it went off.
Mm-hmm.
By the time you get to that part of the sky, sure, a star is where it wasn't before, but like to catch it in the act of exploding, it's almost impossible.
Mm-hmm.
When you find it with your ground-based or these other ground-based surveys, then you could go to the TESS archive data and you could look for that star, and you can get like a pre-light curve. You can literally catch it, sometimes right back to when it exploded. I'm not sure if I explained that properly, but we're getting these supernova, finding them with ground-based surveys that are scanning the sky. But because TESS stares at one part of the sky for a whole month, you could go back and look in the TESS data for your supernova, and you can find it. You can find that light curve of it exploding and getting brighter before your discovery timestamp. If that made sense, could you just explain that a bit better?
I mean, you're getting a little bit of a chronological order here, being able to compare the time. Are you still using data for TESS? I mean, I know your focus is now on Venus, but are you still taking advantage of that data that it's collecting?
Like I myself am not, because after the prime mission was over and everything worked, I stepped down from my leadership role. And what's so cool, I'm really proud of myself and my effort and my team, because they didn't replace me on the mission, because I'd done such a great job in setting it up that it could kind of just run smoothly after that. So for a while I was involved still, like I had students working on the data, or for a while I got to be an author on every paper, because I was one of the 6 or 7, like we called ourselves architects, who like got the mission up and running. And I used to read every single paper that came out of the mission and comment, if I could comment on it or just read it. But no, lately I haven't been involved because I started other things.
I bet there's a little bit of like an ownership, like, oh, that's kind of like my baby at some level. Like we helped get it off the ground, and it was a successful mission. And so yeah, I could see why you'd want to continue
Definitely.
reading all the papers that come out about it and just see how
Mhm.
your baby's doing. One of the other things I saw on your website was the Morningstar missions, which are essentially taking a faster, smaller approach to exploring Venus. I'm curious, why do you think that might be the strategy for
Good
doing?
question. And just to, like, back up a moment, so the Morningstar missions to Venus are the series of mission concepts I started with my team
Mhm.
right after the phosphine on Venus announcement.
Okay.
And so consider the Morningstar missions like an umbrella term and the first mission is the Rocket Lab mission to Venus. So it's really Rocket Lab's mission, but we have a series planned. So why is it the way to go? Well, for Venus, we forgot to mention the idea of life being in the clouds of Venus. It is insane. Even though I tried to rationalize it for you, you know, the biomolecules are there. There's these unusual gases, or the biomolecules can survive in the lab in sulfuric acid. There's these unusual gases. It's still so crazy. It's just still too crazy for most people to digest and accept.
Mhm.
So, in terms of searching for signs of life in the clouds, it's very practical to try to get a private or private public partnership mission because it's not the purview. Like it's not something that large government agencies, it's too tough of a pill to swallow. They cannot go there. They cannot search for life on Venus. It's still too taboo and outside the mainstream. So
Mhm.
that's one main reason. But another reason is in space, these small focus missions could be very complementary to our large government agency missions, right? Because think about Venus. We all have to agree on a mission concept and propose it, and it has to deliver a ton of science. But a lot of people would have to be involved with many instruments, thus making it bigger and more complicated and taking longer to get it off the ground, so to speak.
Mhm.
And so, for a variety of reasons, we haven't sent a probe down into the atmosphere of Venus for over 4 decades. But if we could do something smaller and simpler, it can happen sooner.
Mhm.
So I do think there's definitely a lot of room for this kind of mission.
Mhm. Kinda like, would you call it a pilot program? Let's start small, let's prove it out, and then we've got, evidence to
Yeah,
go to
we can
the
call it.
government
Mhm.
organizations and say, "Let's fund this."
Yeah, we could take this concept, and if it works, we could encourage NASA and other governments to do smaller missions, much smaller missions.
Mhm. Yeah, one of my last questions before I realize we're at time and need to wrap up. Just your opinion on kind of current state. Obviously, you're professor at MIT, and your research and your funding. Obviously, you're trying to get that funded. Want to get supported by NASA. NASA's obviously going through some changes right now. So, just quickly, your opinion on kind of current state. Why do we can want to continue funding NASA, support NASA and fight against their budget cuts. Just current state. What do we think right now is going on, and how do we continue forward?
Well, I can't say what's going on at NASA right now, but I can say that everyone around the whole world loves NASA. Like, you can go to so many countries,
Oh
and
yeah,
people are wearing NASA T-shirts.
wearing the shirts. Oh
You
yeah.
It's human nature to want to explore, and who does that better than NASA? Nobody. And we hope that NASA will continue its missions. Its mission and supporting space, supporting science, and supporting all the amazing discoveries that have come through.
Hmm. Absolutely. I agree with you there. Again, like you said, you could go to other countries, and maybe people are not American. They're not familiar with specific missions, but they know NASA and they know what that meatball symbol symbolizes. Curiosity, inspiration, exploring the universe, and so people get behind that. So yeah, we got to continue to support NASA. And I did notice on your website as well that you had your memoir, and I mentioned it in your bio. So if people wanted to learn more about, your background, your research, your different missions that you've been involved with, where could they learn more?
Well, my website, saraseager.com. We also have a couple of other websites, projectstarshade.com, and for the Morningstar missions to Venus, morningstarmissions.space.
Okay, and your book as well.
And my book and my memoir, it's personal, professional, but it's the arc of my life. But in the book, I try to inspire. Like there's okay, the smallest lights in the universe, it has two meanings. One is the other Earths, remember, they're 10 billion times fainter than their stars, and it's our goal, it's all of our desire to find our twin, our Earth twin out there. But small slice in the universe, also means in that time that I hope you never get there. I hope, like the listeners and you yourself, you never get to like what is essentially rock bottom.
Mm-hmm.
When you're at rock bottom, you have to hold on to like a glimmer of hope. It's really what keeps you going in hard times. And the
Mm-hmm.
smallest lights in the universe, the smallest lights in the universe are also about that. That's what they also mean. Those little glimmers of hope when you're just really just trying to dig out of like a giant deep crevasse.
Mm-hmm.
So it's a story of hope, and it's a story of I was going to go off and like redemption. It's not, but it's, the story of an astronomer, it's just my memoir about my life. And like, it's supposed to inspire everyone to chase your dreams.
It's beautiful. I love it. Okay, well, going on my to read list. Well, I realize that we're right at a time, and so I just want to say, Professor Sara Seager, thank you so much for being here, and thank you for answering all of our questions. I know we covered a lot, and you were a trooper getting all of those questions answered. So thank you so much for joining, and I'm sure the audience would pass on their thanks as well to you.
Thank you very much. It was a pleasure.
And we're going to say a special thanks, like usual, to our executive director, James Burke, our PR director, Michael Stoltz, Leah behind the scenes. Thank you for all of your help, as always. We're going to wrap up today's episode the way that we always do. And I think Sarah would probably agree with this. The best is yet to come. Thanks, everybody. Have a great day. Bye-bye.